Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficent, most merciful. Dear students, I am Dr. Asrar Ahmad and it's my lecture number 6. This lecture is related with the topic third order reactions when only two reactants are involved. This lecture belongs to CHEM 4146 and the course title is Reaction Dynamics. Dear students, in my previous lecture, I have told you that third order reactions are those reactions in which the rate of reaction depends upon the concentration of the exponential values of three reactants. So, if we categorize third order reaction, then depending upon the initial concentration of reactants, third order reactions can be categorized into four categories. Number one, when the initial concentration of all reactants is same. Number two, when the initial concentration of two reactants is same and that of the third reactant is different. Number three category, that this category we will study today, when only two reactants are involved. And the fourth category, which we will study in our next lecture, when the initial concentration of all the reactants is different. Dear students, first category you have studied in my lecture number 4. Second category you have studied in my lecture number 5. And in this lecture number 6, I will guide you how to determine the rate constant expression for the third order reaction when only two reactants are involved. Here one point is very interesting, that the order of reaction is 3, but the interesting point is that the reactants involved are only 2. In general supposition, we suppose that since the reaction is third order, so there should be 3 reactants. Yes, there are 3 reactants, but 2 reactants have the same concentration A and the third is different. This topic is little bit different from my previous lecture that I have studied in my lecture number 5, because this third order reaction when only two reactants are involved. Let us suppose we have two reactants A and B. The concentration or initial concentration of reactant A is written here with small a, and the initial concentration of reactant B is written here with small b. So according to equation, 2 mole of A react with 1 mole of B. So here reactants are only 2, 2 mole of A and 1 mole of B. They when react with each other, they produce some products. So in the previous reaction and the previous lecture you studied, we have 3 reactants A plus B plus C. AB concentration is same and C has different. But here we have only 2 reactants A and B. We don't have third reactant C. So this is the third category of the third order reaction when only 2 reactants are involved. Dear students, let me suppose that when time is 0 second, then product is 0 mole. At that time, A reactant has A mole and B reactant has B mole. But when some time t is passed, let us suppose 1 second, 5 second, 1 minute, 5 minute, 10 minute, then after some time t second, what will happen? These 2 mole of A and 1 mole of B, they will react with each other, they produce some products, and the concentration of the product will be X. Obviously, this product X has been produced by the combination of reactant A and B. So after time t second, the remaining amount of the reactant A will be A minus 2x because here 2 mole of A are involved. So when the product X will be produced, there will be double deficiency in the concentration of reactant A. So here we will write A minus 2x. And the remaining concentration of the reactant B after time t second will be B minus x. Dear students, if we apply rate law to this reaction, then according to rate law dx over dt, it means change in concentration of x with respect to change in time. Rate of reaction dx over dt will be equal to rate constant k into a square into b. A square has been written here because here are 2 mole of A. But when we write the concentration of A and B in terms of their moles, so this rate of reaction dx over dt will be equal to rate constant K into A minus 2x square into B minus x. Dear students, this rate law has been written by taking the concentration of reactant A and B in terms of their mole A and B. So here are two types of terms. Number one, here is dx, in the right hand side is 2x, then b minus x, while in the left hand side dx has been divided by dt time. So if we separate the variables, so after separating the variables, and we will do the integration to solve the equation to find out the value of rate constant. When we separate the variables, it will be written as dx over a minus 2x square into b minus x is equal to k del t. And if we apply the sign of integration, then this equation will be written as has been written in the form of equation number 1. So equation number 1 mean the integration of dx over a minus 2x square into b minus x is equal to k rate constant k into sign of integration into dt. Dear students, equation 1 can be solved by integration, but we have to apply partial fractional method to solve the equation number 1. So when we applied partial fractional method to the left hand side of this equation. So left hand side of this equation in terms of partial fractional method can be written as 1 over a minus 2x square into b minus x is equal to a over a minus 2x plus b over a minus 2x square plus c over b minus x. It is equation number 2. Dear students, here is very interesting point again, because when we take the equation, here are 2 mole of A and 1 mole of B. But when we write in the partial fractional method, so we take these three constants A, B and C. This C was missing in reaction in this reaction. From where this C has been come from? So this C has been come from by using the integration of partial fractional method. When we when we use the partial fraction method, then this equation 2 became 1 over a minus 2x square into b minus x is equal to a over 2 minus x plus b over a minus 2x square plus c over b minus x. So this c over b minus x term has been come from by using the partial fractional method of integration. Dear students, now We will multiply both left hand side and right hand side of equation number 2 with the denominator a minus 2x square into b minus x. So when we multiply the denominator with both the sides of equation number 2, then here at the right hand side only 1 remains. So 1 is equal to a into a minus 2x into b minus x, because this a minus 2x has been cancelled with the square of this a minus 2x, plus b into b minus x, because this a minus 2x square has been cancelled with the multiply term a minus 2x square. So the remaining amount here is b minus x. Similarly, this b minus x will be cancelled out with this b minus x. So this c will be multiplied with a minus 2x square. So according to equation number 3, we got the value 1 is equal to a into a minus 2x into b minus x plus b into b minus x plus c into a minus 2x square. Dear students, this equation is very important because from this equation number 3, we will be able to find the values of C, B and A. In the next lecture, we will find the value of C, then we will find the value of A, then we'll find the value of B. We will put these values again back into equation where all these values have been written in equation number 2. Then we will simplify the equation and ultimately after integration we will get the values of rate constant k. So this equation 1 is equal to a into a minus 2x into b minus x plus b into b minus x plus c into a minus 2x square. At this equation, we apply the condition when b minus x is equal to 0. It means x is equal to b. So, if we apply the term x is equal to b, so this x will be equal to b, this x will be equal to b. So when we will take this x equal to b, so this equation will become this 1 is equal to a into this whole part will be equal to 0. This b will be multiplied with 0. C will be c into a minus 2x 2ab square. So 1 is equal to a into 0 plus b into 0 plus c into a minus 2b square, and this value has been obtained when we take the term b minus x is equal to 0, so x is equal to b. So from this value a will be equal to 0, b will also be equal to 0. So if we separate the term c at one side, this c will be equal to 1 over a minus 2b square. So remember the equation number 4, that according to equation number 4, the value of c is equal to 1 over a minus 2b square. Similarly, dear students, when we solve the equation 3, then we will get the this equation 3, 1 is equal to a into a minus 2x into b minus x. When we will multiply these two terms a minus 2x with b minus x, the resultant product will be ab minus ax minus 2bx plus 2x square. This is simple algebraic rule that you have studied in your metric class. So this a into a minus 2x into b minus x, the product will be a into ab minus ax minus 2bx plus 2x square plus b into b minus x plus c into, so here we will take the square of these two terms, a square plus 4x square minus 4ax. So the equation became very simple if we multiply this a with the terms inside the bracket, b with b minus x, c we multiply c with a square plus 4x square minus 4ax. So this equation will become equation number 5 like this one. 1 is equal to a ab minus a ax minus 2abx plus 2ax square plus b into b minus bx plus c into a square plus 4cx square minus 4cax. So this is the equation number 5 which we have obtained by multiplying a, b and c with the values those have been written inside the bracket. Dear students, in this equation 5, just compare the coefficient of x square. Where are x square? Here, this is x square. Where the next x square? Here, 4. So, this equation number 5, if we compare the coefficient of x square, so this right hand side will be equal to 0 into 2a because we have taken this x square and this x square cancelled out, this 2a plus 4c. So according to equation number 5, if we compare the coefficients of x square, then it will be 2a plus 4c will be equal to 0 or 2a will be equal to minus 4c. For simplicity, if we separate the value of a, then this a will be equal to minus 2 over a minus 2b square. This is the equation number 6. So dear students, from equation number 6, we will get the value of a, and from equation number 4, we will get the value of c. Dear students, now he will find the value of b. Similarly, again equation number 5, if we take it in the form of to get the value of b, then this equation 5 will be equal to 0 is equal to minus a into a minus 2 in a 2a into b minus b minus 4ca. So this b will be equal to minus a into a plus 2b minus 4ca. If we simplify it, then this equation will be written 2 into a plus 2b divided by a minus 2b square minus 4a divided by a minus 2b square, because this is the value of c that I have taken from this equation number a and this one. This is the value of c, 1 over a minus 2b square. Put this value of c in this equation. So you will get b is equal to 4b minus 2a by multiplying this term divided by a minus 2b square, because a minus 2b square is the simple LCM. So the resultant will be 4b minus 2a. This 2a is positive, this 4a is minus. So when we will take the difference 4a minus 2a, here will be 2a. By again taking the common 2, so b will be equal to 2 into 2b plus a minus a divided by a minus 2b square. This is equation number 7. Dear students, from equation 7 we have the value of b, from equation 6 we have the value of a, from equation 4 we have the value of c. Now what we will do with these all values? Very simple. We will put the value of a, b and c from equation 7, 6 and 4 in this equation number 2. So this equation number 2 where a, b and c has been written, we will take the values from equation 4, from equation 6 and from equation 7. So putting the value of a, b and c from equation 7, 6 and 4 respectively in equation number 2. Dear students, When we put the values, then the equation became very complex. So if we simply write the equation, then you can see it that at the this side, equation number 2, 1 over a minus 2x square minus into b minus x. This left hand side is common here. This. This left hand side is common or same as has been written in the form of equation number 2. Here the value of A has been taken. Here the value of B has been written. Here the value of C has been written. So when we write the values of A, B and C and take the common, what the common can be taken from here? Yes, a minus 2b square. This a minus 2b square is also present in this term where the value of a has been written, a minus 2b square where the value of b has been written, and a minus 2b square where the value of c has been written. So if we take the common value 1 over a minus 2b square, the remaining amount here will be minus 2, minus 2, this is minus 2 divided by a minus 2x plus 2 into 2b minus a divided by a minus 2x square plus 1 over b minus x. Dear students, to further solve this equation, we will integrate it. So when we integrate it, the equation, here is the sign of integration, here. So when we applied the integration rules to solve the equation, so this equation became like this one, that 1 over a minus 2b square into sign of integration minus 2 over a minus 2x into dx minus 2b minus a sign of integration a minus 2x raised to power minus 2 into minus 2 into dx minus sign of integration minus 1 divided by b minus x into dx. So here k into sign of integration into dt, when we will integrate this right hand side, it will be kt plus c. C is the integration constant, k is the rate constant and t is the time. So dear students, when we applied the rules of integration to these values that are to these terms written inside the bracket, so this side will be written as log natural a minus 2x. This log natural a minus 2x minus 2b minus a into a minus 2x raised to power minus 2 plus 1 divided by minus 2 plus 1. I have told you already this formula has been applied. This is called power rule. Minus log natural into b minus x. So when we further simplify the terms inside this bracket, 1 over a minus 2b square into log natural log natural into a minus 2x plus 2b minus a over a minus 2x. This terms have been written in the simplified form. This 2b minus a divided by, here is the value of minus 1 because minus 2 plus 1 difference is minus 1. So we will write this value in the denominator a minus 2x into log natural minus log natural into b minus x is equal to kt plus c. Dear students, next is the simple logarithm formulas. According to natural log formulas, these values can be written as log natural a minus 2x divided by b minus x. This is b minus x because here the simple rule is log m minus log n will be written log m over log n. So log natural a minus 2x will be divided with b minus x plus 2b minus a over a minus 2x, that has been already proved. So it will be equal to kt plus c. Dear students, this is the equation number 8, and this equation number 8 is very important to determine the rate constant k, because if we know the value of c, we will put the value of rate integration constant c here in this equation number 8, then this value of c will be taken on the right hand side, there it will be subtracted, and after simplification we will get the value of rate constant k. So this equation 8, if we apply the initial conditions when time is equal to 0 second and x is equal to 0, so this equation will become like this one, 1 over a minus 2b square, simple common, log natural a, here 2 minus 2x is 0 because x is equal to 0, here b because x is equal to 0, plus 2b minus a divided by a because x is equal to 0, so 2x will be 0. And t is since also 0, so this k will become instantaneously it will be 0. So we will find the value of c, that is the integration constant. This value of integration constant c is 1 over a minus 2b square into log natural a over b plus 2b minus a over a is equal to rate integration constant c. Dear students, now what we will do? We put this value of c, integration constant, back into this equation number 8. So after writing this equation 8 will become similarly the right hand side of which at which side my cursor is moving. This side will be the same as has been written here. This one, this. If you remember, if you see, this right hand side of equation number 8 is just like same, and this left hand side where the value of c has been written, this value of c is 1 over a minus 2b square into log natural a over b plus 2b minus a over a. So in the next step what we did, we subtracted this value of c on the left hand side. So this value of c was subtracted on the left hand side. So here is the value of kt. Here is the same value that was written on the left hand side of equation number 8, 1 over a minus 2b square into log natural a minus 2x over b minus x plus 2b minus a over a minus 2x. Here is the minus, this is the difference. So this is the value of c. Dear students, if you see it very deliberately, you will find one thing is common here. That is 1 over a minus 2b square. This is the common term here. So we take the common term out of the square bracket, 1 over a minus 2b square into log natural a minus 2x over b minus x plus 2b minus a over a minus 2x minus log natural, this one, this log natural, a over b plus 2b minus a over a. This whole equation is equal to rate constant kt. Dear students, now in the next term we will simplify the equation, this one. How? 1 over a minus 2b square, that was the common term here, log natural b into a minus 2x over a minus a into b minus x. So what we did here, that the term here a over b minus log natural, we just simply applied the logarithmic rule that log m minus log n is equal to log m over log n. So this a minus 2x will be multiplied with b and b minus x will be multiplied with a. So log natural b into a minus 2x divided by a into b minus x plus 2b minus a, it is the common term here, yeah, 2b minus a divided by a minus 2x. So here what he did, 2b minus a was taken common. So the remaining amount here will be 2b minus a, that is the common term, into 1 over a minus 2x minus 1 over a. And if we just open the terms inside the bracket, then we will get the result 1 over a minus 2b square into log natural. This b into a minus 2x divided by a into b minus x plus 2b minus a. So what we did, we take the LCM of this small bracket. And after taking LCM, this part of the bracket became a minus a plus 2x divided by a into a minus 2x. So after simplification, this side became 1 over a minus 2b square, this term. This a minus 2b square that has been written in the denominator, we multiplied it with kt here. We multiplied a minus 2b square on both sides. Here it is cancelled, and this a minus 2b square has been multiplied with this kt. So this equation became log natural b into a minus 2x divided by a minus a into b minus x plus 2x into 2b minus a, because this is 2x, this one, and 2b minus a, this one. This a and a has been cancelled, divided by a into a minus 2x. This a into a minus 2x is equal to a minus 2b square into kt. This is the equation number 9, and this is our required equation, because this equation number 9 is very important, because from this equation we will be able to determine the value of rate constant. How this value can be find out? Just we will draw a graph. Along the x-axis we will take time, and along the y-axis we will take a minus 2b square. Along y-axis a minus 2b square values, and along x-axis we take the value of time. Then we will get a straight line, and this straight line will pass through the origin. Dear students, the value of slope will be equal to a minus 2b square into rate constant k, and this rate constant k can be obtained by just dividing the value of slope from the graph divided by a minus 2b square values from the y-axis. So the rate constant for the third order reaction when only two reactants are involved, this rate constant expression can be derived. Dear students, I hope you have listened the lecture and watched the different mathematical points that I have discussed or described to you. I hope you will have understood it. In case if you have some question about any point, any equation, then you can discuss with me on my Google class. Thank you very much. Thank you very much.